So experimental design is a traditional approach in conducting quantitative research. So of course, in an experiment, you need to test an idea to determine whether it influences an outcome. So how? Of course, firstly, we need to choose an idea to experiment. And next is we need to assign individuals or groups to experience it, as well as having some individuals who experience something different. And lastly, we need to determine whether those who experience the idea perform better than those who did not experience it. When did experiments develop? Experimental research began in the late 19th and early 20th century with psychological experiment. In 1903, Schuler used experimental and control groups. In 1916, McCall advanced the idea of randomly assigning individuals into groups, authoring a major book in 1925 on how to conduct an experiment. McCall again firmly established the procedure of comparing groups. So in 1936, Fisher's book, The Statistical Methods for Research Workers, discussed the statistical procedures useful in experiments in psychology and agriculture. In this book, Fisher's advanced the content of randomly assigning individuals to groups before starting an experiment. So by 1963, Campbell and Stanley had identified the major types of experimental designs. They specified 15 different types and evaluated each design in terms of potential threats to validity. So in 1979, Cook and Campbell elaborated on the types of designs, expanding the discussion about the validity threats. So in 1980s, experiments have grown in sophistication and complexity, large because of computer and improved statistic procedures. So in 2002, Shadish, Cook, and Campbell had defined the discussion about the major experimental designs. So random assignment is a process of assigning individuals at random to groups. So it is made to be more fair, not biased, and so that each of every individuals who have different personal characteristics is well distributed. So control over extraneous variables is by randomization, you provide control over the extraneous characteristics of the participants that can influence the outcome. So for example is their attention span, their motivations, and their ability. So under this, we have the term equating the group. So equating the group means the researcher randomly assigning individuals to a group. Other control procedure you can use both before and during the experiments are pre-tests. Pre-test is the test given before the treatment. Next is the post-test. The post-test is the test given before the treatment, after the treatment rather. The covariates is the score on the pre-test, but also they might be any correlated, or they might be variables correlated with the dependent variables. Next is the homogeneous samples, which are people that is being selected because they are the people who vary very little in their personal characteristics. So, for example, is their academic performance and their religious groups. So, next is the matching of the participants. So, the matching of the participants is the process in which they are identifying one or more person characteristics that can influence the outcome and assigning that individual into different groups, just like the experimental and the control groups. And lastly is the blocking variables. So blocking variables is when dividing or blocking the participants into subgroups, manipulation of the treatment conditions. So the researcher physically manipulate the treatment condition for one or more groups. So the control group receives no manipulation of the independent variable, whereas the experimental group receives the manipulation of the independent variable. So treatment variables. Treatment variables is also called independent variables. So in experimenting, you need to focus on independent variable because it is the one who affects the dependent variable or the outcome. So in experimenting, treatment variables are the variables that the researchers manipulates to determine their effect on the dependent variable or the outcome. Conditions. So in experiment, the treatment variable needs to have two or more categories or levels. So be reminded that levels are the category of treatment variables. So in the book, we have these examples that if you decided to divide the types of instruction. So it is divided by 3. So first is standard civics lecture. Next is standard civics lecture plus discussion about the health hazard. And last is the standard civic lecture plus discussion about the health hazard and a picture or a slide of a damaged outcome measures. So outcome measures, which also called the dependent variable. So in experiment, the outcome is the dependent variable, that is the presumed effect of the treatment variable. As I said earlier, that the independent variable is the treatment variable, which is the one who influenced the outcome measures or the dependent variable. So it is also the effect predicted in the hypothesis in the cause and effect equation. And also, and the example of this is, or the examples of dependent variables in experiments are the test scores on an aptitude test, group comparison. So group comparison is the process of a researcher obtaining scores for individuals or groups on the dependent variable and comparing the means and variance both within the group and between the groups. So as it is in the title, group comparison, so this is when the researcher obtain the scores of individuals or group and compare it to the other groups. So next is the threats to validity. Threats to validity refer to the specific reason for why we can be wrong when we make an inference in an experiment because of covariance. Causation constructs or whether the causal relationship holds over variation in persons, settings, treatments, and outcomes. Four types of validity. So first is the statistical conclusion validity, which refers to the appropriate use of statistics to infer whether the presumed independent and the dependent variable could vary in the experiment. The next is the construct validity. So, construct validity means the validity of inference about the constructs in the studies. So, internal validity. Internal validity relates to the validity of inferences drawn about the cause and effect relationship within the independent and the dependent variables. So, external validity, the last one. External validity refers to the validity of the cause and effect relationship being generalizable to other persons, settings, treatment variables, and measure. The next category addresses threats related to treatments used in the study. So first is the diffusion of treatments. So the diffusion of treatments is when the experimental and control groups can communicate with each other. It can create a threat into internal validity because the control group can learn or may learn from the experimental group about the information about the on what is happening in their experiment or what type of treatment they are receiving. So next is the compensatory equalization. So the compensatory equalization is when only the experimental group receives a treatment, an equality exists that may threaten the validity of the study. The benefits of the experimental treatment need to be equally distributed among the groups in the study. So, being unfair in this, in the experiment, especially in giving or disseminating treatment, it can cause a threat. So next is the resentful demoralization. It is when a control group is used, the individual may become resentful as they think that they receive less desirable treatment than other groups. So it's about jealousy like that. So next one is the compensatory rivalry. So if you publicly announce assignments to the control and experimental group, compensatory rivalry may develop between the groups because the control groups feels that it is underdog, or researchers can try to avoid this threat by attempting to reduce the awareness and expectation of the presumed benefit of the experimental treatment. So in this, the following category addresses threats that typically occur during the experiment and relate to the procedure of the study. So we have testing and instrumentation. So in testing, potential threat to internal validity is that the participants may become familiar with the outcome measures and remember responses for later testing. So when the participants become familiar with the outcomes and if they try to remember it for the later testing, it can be a threat. The next threat is the instrumentation. So instrumentation is between the administration of a pre-test and a post-test. The instrument may change, introducing a potential threat to the internal validity of the experiments. So, threats to external validity. Threats to external validity are problems that threatens our ability to draw correct inference from the sample data to other person settings, treatment variables, and measures. So according to Cook and Campbell in 1979, there are three threats that may affect this generalizability. So first is the interaction of selection and treatment. This threat to external validity involves the inability to generalize beyond the groups in the experiment, such as other racial, social, age, gender, or personality groups. So this threat develops when they generalize beyond the groups that will be involved in the experiment. So it is in terms of their social, age, gender, or personality. Next is the interaction of setting and treatments. This threat to external validity arises from the inability to generalize from the setting where the experiment occurred to another setting. So in this threat, the threat develops when they are generalizing the settings. So lastly is the interaction of history and treatment. So this threat to external validity develops when the researcher tries to generalize findings to past and future situations. So in threat, uh, this threat develops na when they are trying to generalize the findings from the past and the future situations.
Hi everyone, good morning. My name is Elaine Joyce M. Magparangalan, and I was assigned to discuss this subtopic, the types of experimental design, and the second one is the ethical or the potential issues in experimental research. Now, without further ado, let's begin. First off, um, what we have here is between group design, one of the types of experimental designs. So in between group design, it is a research method where different groups or participants are compared under different conditions or treatments. So here are some independent between groups design. First off, we have the independent group design. The second one is match group design. The third one is we have repeated measures design. And the fourth one is we have counterbalance design. Now, what is independent group design? All right. Now, independent group design are these are the participants that are randomly assigned to different groups, with each group experiencing a different condition or treatment. So, say for example, one group might receive a new teaching method, while another group receive the traditional method. Okay. Now, for the second one is we have match group design. Now, in match group design, participants are matched based on certain characteristics such as, say, for example, age, gender, or maybe academic ability. And then they are randomly assigned to different groups. And this actually helps to control for individual differences that could affect the result. Now, the third one is we have what is the repeated measures design. Now, in repeated measures design, participants experience all condition or treatments, but but in a different order, of course. Say, for example, one group might receive treatment A or treatment B, then a treatment B or a treatment A. Or to make it more specific, we can say that um, one group might receive the treatment B first, then the treatment A. All right. Now, the fourth one is we have counterbalance design. Now, in counterbalance design, participants experience all conditions or treatments, but the order in which they receive them is systematically varied across participants to control for order effects like learning or fatigue. So, say for instance, half the participants might receive the treatment A, followed by treatment B. Then while the other half receive treatment B, followed by treatment A. Now let's proceed to the next experimental design, which is the true experiment. Now, a true experiment, it states here, a true experiment involves random assignment of participants to group or unit. This form of an experiment is the most rigorous and controlled of all types. This was based on the PDF that we sent to us. In this research method, researchers can manipulate one or more independent variables and measure their effects on one or more dependent variables, while, of course, controlling for other potential influences to establish cause and effect relationships. Now, when we say through experimental or through experiments, we can typically involve random assignments of participants to different experimental conditions or treatments, ensuring that any observed effects can be attributed to the manipulated variable rather than to other factors. Now we have here some key features of a true of a true experiment. So the first one is we have the manipulation of variables. The second one is we have the random assignment. The third one is we have control group. The fourth one is we have experimental group or experimental control. Now, next one, if we have the quasi-experimental design. When we say quasi and experimental design, it is a research method that shares similarities with true experiments, but of course, it is lack one key feature, which is the random assignments of participants to different experimental conditions or treatments. In quasi-experimental design, researchers still manipulate independent variables and measure their effects on dependent variables, but they do not use random assignment. Again, when we say quasi-experimental design, it doesn't use the random assignment. Okay. Now we have its key features here. First, if we have manipulation of variables, no random assignment. Again, no random assignment are included in the quasi-experimental design because we don't have the control assignment. Now we have the control group. The fourth one is we have the less control over extraneous variables. Okay. Now let's move on to the next one, which is the factorial design. Now, in factorial design, we can say that this research method is involved studying the effects of two or more independent variables simultaneously. So each independent variable has multiple levels or conditions, and all possible combinations of these levels are tested as well. This allows researchers to examine the main effects of each independent variable as well as many interactions between them. Okay? Now, say for example, in a 2 by 2 factorial design, there are two independent variables. Now, each with two levels, resulting in four experimental conditions. Okay? It has a two um, levels that, of course, result in a four experimental conditions. Now, its key features are in here. First, it involves studying the effects of two or more independent, which was stated in its definition. The second one is each independent variable has multiple levels or condition. The third one is all possible combinations of levels are tested. Again, it was stated on the definition of factorial design, again, of course, as well, rather. Then the next one is we have allows examination of main effects and interactions between variables. Now let's move on to the next design, which is the within group or within individual procedure. Within group or within individual procedure, there are research design where participants serve as their own controls, experiencing all condition or treatments in the study. So in other words, within group or within individual procedure refers to a research design where participants serve as their own controls. Again, it is the participant of this design are served as their own controls. Okay, and experiencing all conditions or treatments in the study. So, say for example, participants might receive both a treatment condition and a control condition, with the order of condition counterbalance to control for order effects. Within group or within individual procedure are often used in repeated measures design. Now, next one is we have the time series design. Now, time series design involves measuring the same variables repeatedly over a period of time, both before and after an intervention or treatment is implemented. So, this allows researchers to examine trends and patterns in the data over time, as well as the effects of the intervention. Time series designs are commonly used in fields such as economics, public health, and sociology to study changes in behavior outcomes or other phenomena over time. And what we are seeing here is its key features that were also included through my explanation. Okay. Now, next one, if we have the repeated measures experiment. Now, in here, repeated measures experiment is a research design where participants are measured on the same dependent variables multiple times under different conditions or treatment. This can involve within group comparisons. So, just like what I have said earlier, the within group or the individual group design are involve the repeated measures experiment. just like in here, the repeated measures experiment were involved they within group comparison. So repeated measures design are useful for controlling individual differences and increases statistical power by reducing variable or the variability among participants. Within group comparison, repeated measures experiment or these repeated measure experiment are commonly used by it. Okay. Now let's proceed to the next one. We have the single subject design. So in a single subject design, a research design studying the behavior of individual participants over time, where various interventions or treatments are implemented and behavior is measured before, during, and after each intervention. Now, in single subject design, this is also known as a single case experimental design. As what I have said, it involves studying the behavior of individual participants over time. Okay. Now that we have mentioned the experimental, all the types of experimental design, now let's proceed to the ethical issues in experimental research. Now, in experimental research, there are, let's say, red flags that we have to watch out for. Okay? Because I think in all aspects, red flags can't be denied o hindi maiiwasan yung mga red flags. Ano? Now, let's discuss the ethical issues in experimental research. Ethical issues in experimental research involve various concerns related to the treatment of participants and the impact of the research on society. Some key ethical considerations include the informed consent. The second one is the privacy and confidentiality. The third one is we have the harm and the risk or minimizing harm. The fourth one is we have fair treatment. The fifth one is we have deception and debriefing. Actually, we still have a lot of ethical issues in experimental research, but I just have included this one because these are the important ethical issues that we need to watch out for. Okay. Now, in informed consent, we have to make sure that participants know what they're getting into, and we have to make sure that they are willingly or voluntarily agree to participate within any portion or with your study. You must make sure that your participants are willingly and voluntarily um, participated on your um, study. So, what is the importance of having informed consent? When we say, or let's say, the importance of having this informed consent is to respect the autonomy and rights of participants. Because in informed consent, it ensures that individuals have the necessary information to make an informed decision about whether to participate in the research, and it helps to establish trust between researchers and participants. What if maybe on your next study, that participant, uh, pwede mo siyang kunin ulit kasi your target participants are someone like you or like her. So, may trust na mangyayari kapag you have the informed consent or kapag nagbigay ka ng consent sa participants mo. Alright? Now, the next one is we have the privacy and confidentiality. Now, in privacy and confidentiality, these protect participants' personal information and ensure their privacy is respected throughout the study. So, say, for example, researching or researchers conducting interviews with participants about sensitive topics such as mental health or personal experiences. So take precautions to anonymize data and store it securely. They ensure that only authorized personnel have access to the information collected. So what is the importance of this? The importance of this is that privacy and confidentiality protect the personal information of participants and uphold their right to privacy. It helps to build trust between participants and researchers encourages honest responses and prevents the potential for harm or embarrassment if a sensitive information were to be disclosed within consent. All right, just like in informed consent, we can build a trust between a participant and me or the with you, the researchers. So we cannot only, let's say, we cannot only build the trust between the participant and us, but also we can get a true and makukuha natin kung yung totoong na experience ng participant, kung when we interview them, mas um, mas clear yung ibibigay nilang information with you na of course aligned sa study mo. Okay? Now next one is we have harm and risk or the minimizing the harm. So in conducting our study, we have to be cautious of any potential physical or psychological harm that participants might face during the study. So we have to minimize risk as much as possible dito, no? So in ethical issues in experimental research, we also have to minimize harm or as much as possible, let's minimize harm to our participants. I think this includes or this involves to all types of research, mapa-quanti man to or mapa-quali. Okay, now next one is we have the fair treatment. Now, in fair treatment, all participants should be treated fairly and without discrimination based on various factors such as age, gender, race, or socioeconomic status. Okay? Now, say for example, here in fair treatment, researchers ensure that recruitment methods for a study are inclusive and accessible to individuals from diverse backgrounds. They avoid biases in participant selection and strive to represent of the population in their sample. Okay, so what is the importance of this fair treatment? So fair treatment promotes equity and justice in research participation. It ensures that all individuals have an equal opportunity to participate and contributes to the validity and generalizability of research findings by representing a broad range of perspectives and experiences or the experience. The next one is we have the deception and debriefing as well. Now, in deception, it should be minimized and participants should be debriefed afterward to ensure they understand the true nature of the research. And the next one is we have the debriefing. After the study, provide participants with information about the purpose of the research and address any questions or concerns they might have. And of course, in the briefings, the researchers should respect the participants as well, treat them equally, and treat the participant with respect, dignity throughout the study process. And actually, we can also, when conducting a research, we can also debrief or like bigyan na natin, i-briefing na natin kagad yung participants natin about our studies, about what is the purpose of our studies so that they will give enough information and hindi sila mag dalawang isip na mag-participate sa study natin. All right, and now that concludes my topic. Thank you so much for listening and
As we have learned about the different types of experimental designs, we have also begun to understand some of the procedures involved in conducting an experiment. Although there is no set procedure for conducting an experiment, it is better to understand the general process before you begin. So, what are the steps in conducting an experimental research? First step is decide if an experiment addresses your research problem. The research problem stays set as a foundation for the entire study. The type of issues studied by experimenters is the need to know whether a new practice influences an outcome. By conducting an experiments, researchers can systematically test the effectiveness of the new interventions, treatment, or practices, and also to provide valuable insights into their efficacy and potential benefits. The next step is to form hypotheses to test cause and effect relationships. A hypothesis advances a prediction about outcomes. The experimenter establishes these predictions in the form of null or alternative hypothesis, and then collects data to test the hypothesis. Hypotheses are specific, testable statements that predict the relationship between variables. So, stating an experimental hypothesis, you need to follow these guidelines. First is that independent variables should contain at least one variable and multiple levels, and one of these levels were being manipulated by the researchers. So, manipulating one of the levels enables researchers to compare the outcome across different conditions, helping to establish cause and effect relationship. So dependent variables are outcomes, and experimenters often study multiple outcomes. Researchers investigate multiple dependent variables to gain a more comprehensive understanding of the effects of the independent variables. Let's proceed to the step 3. Select an experimental unit and identify student participants. An experimental unit of analysis is the smallest unit treated by the researcher during an experiment. It refers to an individual or subject on which the measurements or observations are made in experiment. So for example, a clinical trial testing the effectiveness of a new medication, the experimental unit may be the individual patient. And the appropriate experimental unit is crucial for ensuring the validity and interpretability of the study results. When we use the term treated, we are referring to the experimental treatment. Participants may be assigned to different treatment conditions or groups, with some receiving the experimental treatment, the treated group, and the others serving as control. So these questions will be aligned on how to select an experimental unit and to identify study participants. Who will participate in your experiment? Investigators may choose participants because they volunteered or they agreed to be involved. Alternatively, the researcher may select participants who are available in well-defined, intact groups that are easily studied. Next question is, how many people will you study? An ideal experiment, the researcher forms at least one control and one experimental group. The control group serves as a baseline for comparison and does not receive the experimental treatment. The experimental group receives the treatment or intervention being studied. Next is that, how should the participants be chosen? Possible, you should randomly select individuals for the experiment from the study population so that inferences can be made from the results to the population. Next is that, how should the individual be assigned into groups? As optimal situation is to randomly assign the individuals into groups. It helps minimize potential biases and ensure that groups are comparable at the outset of the study, but this procedure may not always be feasible. The step 4 is select an experimental treatment and introduce it. The key to any experimental design is to set levels of treatment and apply one level to each group, such as one level to an experimental group and one level to the controlled group. In deciding what interventions to use, you might consider several factors. First factor is the experimental research should select an intervention of adequate dosage. This means that the intervention must last long enough and be strong enough to actually have an impact on the outcome. Second factor is a good intervention is one that has been used by other researchers and it should predict a change in the outcome. When an intervention has been previously tested by other researchers, it provides a strong rationale for its use in a new study. Next factor is experimental research should choose an intervention that can be implemented with as little intrusion in the setting and on the participants as possible. Choosing interventions that can be implemented with minimal disruptions help maintain the ecological validity of the study, ensuring that the findings accurately reflect real-world conditions. The last factor is choose an intervention based on a small pilot test. It is a process where the researchers select a group of participants in the population and provide the intervention to them. By testing the intervention on a small scale, researchers can assess its feasibility, acceptability, and potential effectiveness before committing to a full-scale implementation. The step 5 is to choose a type of experimental design. It is previously discussed the type of experimental design. So as a researcher, you need to choose an experimental design that fit your research. Choosing the right experimental design is crucial because it directly influences the validity and reliability of your results. Next is the step 6, conduct the experiment. Conducting an experiment involves procedural steps. Consist with the design selected. It may involve administering a pretest if you plan to use one. So pretest can help identify potential confounding variables or differences among groups before the experiment begins, enabling researchers to account for them in their analysis. Second is introducing the experimental treatment to the experimental group or relevant group. It involves implementing the intervention, manipulation, or condition that is being tested to observe its effect. Next is monitoring the process closely so that threats to internal validity are minimized. It helps ensure that the study's design and execution are strong, reducing the potential for confounding variables or biases to affect the results. Next is gathering post-test measures, the outcomes or dependent variable measures. These measures help assess the effects of the independent variables on the variables of interest, providing insights into the effectiveness of the experiments. Next is using ethical practices by debriefing the participants by informing them of the purpose and reasons for the experiments. Step 7 is to organize and analyze the data. There are 3 major activities required at the conclusion of the experiment. First is the coding the data. Researchers need to take the information from the measures and set up a computer file for data analysis. Second is the analyzing the data. It involves applying statistical techniques or other methods to examine patterns, relationships, and significance within the collected data, ultimately providing insights into the research questions or hypotheses. Writing the experimental report. The report typically includes details about the research design, the methods, results, and the conclusion, allowing others to understand the experiment's purpose, procedures, and outcomes. Last but not the least is the step 8, develop an experimental research report. The experimental report follows a standard format in the methods or procedures section of an experiment. The researcher typically includes information about participants and their assignment. This includes details such as the demographic characteristics of the participants, how they were recruited, any inclusion or exclusion criteria, and how they were assigned to different experimental conditions or group. Next is the experimental design. This includes details such as the type of design used, how variables were manipulated and measured, and any control measures implemented to ensure the validity of the study. Next is the intervention and materials. Detailing the intervention involves describing the actions taken by the researcher to manipulate the independent variables and any procedure for controlling extraneous variables. Materials encompasses the tools, equipment, and resources employed during the experiment, such as the questionnaires, the stimuli, apparatus, or software. Next is that control over extraneous variables. It involves detailing the strategies implemented to minimize their potential influence on the study's outcomes. Lastly is the dependent measures or observations. This involves explaining what variables were measured or observed during the experiment to assess the effects of the independent variables. This section should outline how the dependent measures were collected, recorded, and analyzed to ensure the study's validity and reliability. After knowing the steps in conducting the experimental research, we will now proceed on how do we evaluate the experimental research. So here are the criteria. First is that the experiment has a powerful intervention. A powerful intervention means that the treatment or manipulation applied to the participants or the subjects has a significant impact on the dependent variables being measured. Intervention should be relevant to the study or to the research question and hypothesis. Second is that treatment groups are few in number. Having a small group of treatment groups can sometimes be advantageous in experimental research. This can simplify the analysis and interpretation of results. It easier to identify the effects of the independent variables. Third is that participants will gain from the intervention. Ethical research practices prioritize the well-being and right of the participants, ensuring that any potential risks are minimized and that participants are treated with respect and dignity. Next is the researcher derives the number of participants per group in some systematic way. This involves ensuring the samples. This method includes the ensuring the sample size is appropriate to detect the meaningful effects and achieve the sufficient statistical power. Careful planning of consideration in determining the number of participants per group to achieve reliable and generalizable findings. Next criteria is an adequate number of participants were used in the study. Adequacy of sample size depends on various factors such as research question, study designs, effect size, statistical power, and anticipated variability. A good experiment should aim to recruit a sample size that is large enough to detect meaningful effects and ensure the reliability and generalizability of the study. Next criteria is the researcher uses measures and observations that are valid, reliable, and sensitive. Validity, it refers to the extent to which a measure accurately assess the intended construct or variable, ensuring that the results reflect the phenomenon under investigation. Reliability refers to the consistency and stability of the measures over time and across different conditions, indicating the extent to which the results are dependable and reproducible. Sensitivity refers to the ability of the measures to detect meaningful changes or differences in the variables being studied, ensuring that the experiment can effectively capture the effects of the intervention or treatment. The next criteria is that the researcher controls for extraneous factors that might influence the outcome. This involves identifying the minimizing potential sources of bias or confounding variables that could affect the validity and reliability of the results. Next criteria is the research addresses threats to internal and external validity. Internal validity refers to the extent to which the observed effects can be confidently attributed to the independent variables being manipulated rather than the other factors. Researchers should employ accurate experimental designs, control for irrelevant variables, and use appropriate measures and procedures. External validity, on the other hand, concerns the generalizability of the findings beyond the specific conditions of the study. Researchers can enhance external validity by using representative samples, replicating the study in different settings or population. A good experiment should carefully consider and address potential threats to both the internal and external validity to ensure that the findings are reliable and applicable to the real-world context. So that ends our discussion. I hope that you learned something about experimental designs.